Hello again, everyone. Welcome to the final lecture of Module 2. In this lecture, we'll be discussing ethics in research. Over the past two lectures, we've explored how psychologists design studies and ensure their findings are reliable. From operationalizing variables to running controlled experiments, we've seen how science helps us to separate fact from fiction. But today, we're tackling an equally important question. How do we ensure that research respects the rights, dignity, and well-being of all of the people involved? Before we jump into that, let's quickly review some key ideas from Lecture 2.2. What is the primary purpose of random assignment in a controlled experiment? A, to ensure the sample reflects the larger population. B, to control for confounding variables by balancing differences between groups. C, to minimize the likelihood of bias in participant responses. Or D, to establish a correlation between variables. The correct answer is B. Random assignment helps to ensure that differences between groups are due to the independent variable, not pre-existing characteristics. Next up, why can't correlational studies demonstrate causation? A, correlational studies do not involve manipulation of variables, so other factors may explain the relationship. B, correlational studies are only conducted with small sample sizes, reducing the reliability. C, correlational studies rely solely on self-reported data, which can be biased. Or D, correlational studies measure variables at different time points, making it impossible to establish cause and effect. The correct answer is A. Correlational studies measure relationships between variables, but do not manipulate them, which leaves open the possibility of confounding variables explaining this association. Now let's shift our focus to today's topic, ethics in research. In this lecture, we'll be discussing a horrifying abuse of ethics that occurred in Tuskegee, Alabama. We'll be reviewing several different ethical principles in research, as well as the organizations that enforce them, institutional review boards. We'll then be getting into the replication crisis in science before concluding and reviewing. Let's dive into it. What if I told you that in the pursuit of knowledge, some researchers have ignored basic principles of human dignity and respect? Would you say that's acceptable if it leads to groundbreaking discoveries? Valuing knowledge above ethics has led to some of the darkest chapters in scientific history. One infamous example is the Tuskegee syphilis study, a case that highlights the devastating consequences of unethical research. To start, let's watch a brief video that outlines what happened during this study. This video comes from the YouTube channel Night Terror and is available through a Creative Commons license with attribution.
Number 2. The Tuskegee Syphilis Study. The Tuskegee study of untreated syphilis in the Negro male, to give this next experiment its full title, was an extremely unethical study conducted between 1932 and 1972 by the US Public Health Service. To begin, 600 participants, all of which were impoverished African American men, many of whom had never visited a doctor before, were told that they would be receiving free health care from the United States government to treat bad blood, a term used in the area to refer to a variety of health issues. However, not only were none of the participants informed of their actual diagnosis, none gave any sort of informed consent that indicated they agreed to taking part in a clinical study of this nature. Of the 600 unknowing participants, 399 had already contracted syphilis prior to the study, and 201 formed the control group of participants who did not have the disease. During the study, the men were given no effective care or treatment for syphilis, and instead were given things such as aspirin and mineral supplements, things which the researchers knew were ineffective against the disease. Treatment, however, was not the purpose of this particular study, and as the name suggests, the real research being conducted during this 40-year experiment was on the natural history of untreated syphilis and its devastating effects on the human body. Some 15 years after the study began, penicillin had become the recognized standard treatment for syphilis, However, researchers continued to leave the participants without effective treatment and withheld penicillin and information about it from participants, even going so far as to deny them access to treatment programs that were being offered to other local residents. One particularly shocking aspect of this whole event was that it was revealed that in 1996, a full 6 years prior to the termination of the study, Peter Buxton, a venereal disease investigator from San Francisco, sent a letter to the National Director of the Division of Venereal Diseases, expressing his concerns about the ethics of this particular study. The Center for Disease Control, or CDC for short, which controlled the study by that time, had stated that the study would continue until all subjects had died. The study, however, only concluded when a leak was finally made to the press in 1972, which led to the termination of the experiment on the 16th of November that same year. Tragically, by the end of the study, of the 399 men who originally had previously contracted the disease, only 74 of them were still alive. 28 of them had died from the disease itself. Another 100 died from related complications. 40 of their wives had been infected with the disease, and 19 children were born with congenital syphilis. If any good came out of this experiment, it's that in 1974, Congress passed the National Research Act and also created a commission, the National Commission for the Protection of Human Subjects of Biomedical and Behavioral Research, whose purpose is to study and write regulations governing studies involving human participants. The result of which now requires that participants must give informed consent, must be informed of a diagnosis, and the studies themselves must provide an accurate report of the results.
Take a moment to think about what you just saw. This study involved deliberate deception, harm, and the exploitation of vulnerable individuals, all in the name of research. The Tuskegee syphilis study serves as a stark reminder of why ethical guidelines in research are not just important, they're absolutely essential. They protect participants, uphold human dignity, and ensure that science serves society responsibly. So how do we prevent tragedies like Tuskegee from happening again? Over time, the scientific community has developed a set of ethical principles to guide research and protect participants. Let's explore these principles and see how they apply to modern research. The Tuskegee syphilis study highlights the dire consequences of ignoring ethics in research. And to ensure that science respects human dignity, the scientific community follows a set of ethical principles. These principles act as guide rails, protecting participants and ensuring that research is conducted responsibly. We'll be discussing 5 different principles: voluntary participation, informed consent, minimizing risks of harm, confidentiality, and anonymity. The first principle is voluntary participation. People must freely choose to participate in research. We want to make sure that participants are not coerced or under undue pressure. We uphold this value by clear communication that participation is optional, and by ensuring that there are no penalties for choosing not to participate or withdrawing. Next, let's discuss informed consent. Informed consent ensures that participants know what they're getting into. This means explaining the study's purposes, procedures, potential risks, and participant rights. A researcher might downplay the risks of a study or fail to mention potential side effects of a treatment, but without full disclosure, participants can't make informed decisions. We uphold this standard by using clear, non-technical language in consent forms. We provide opportunities for participants to ask questions before agreeing to take part. Next, researchers have an obligation to minimize potential harm, both physical and psychological. Imagine a study that induces high levels of stress in participants without offering support or safeguards. This can lead to emotional harm. We uphold this principle by conducting risk assessments before beginning a study. We offer support resources like counseling if distress occurs. Next up is confidentiality. Confidentiality means keeping participants' information private and secure. Participants should trust that their data won't be shared without their permission. A researcher studying sensitive topics like drug use, accidentally revealing a participant's identity is a major breach of trust and privacy and can have significant consequences for the participant. We uphold confidentiality by using pseudonyms or codes instead of real names. We store data securely using encryption and restricted access. Anonymity goes a step further, ensuring that participants are completely unidentifiable, even to the researchers. We uphold anonymity by avoiding collecting identifying information unless absolutely necessary. We use tools that anonymize responses, like secure survey platforms. We make sure that we are collecting the minimum amount of information needed. Let's do another attention check. What is the primary purpose of informed consent in research? A, to ensure participants fully understand the study and voluntarily agree to participate. B, to allow researchers to collect identifying information for follow-up studies. C, to prevent participants from withdrawing once they've agreed to participate. Or D, to ensure researchers can minimize costs and maximize sample sizes. The correct answer is A. Informed consent ensures participants understand the study, including its risks and benefits, and voluntarily agree to take part. Take a moment to reflect. Think about a scientific study that we discussed in class, or maybe that you've read elsewhere. What ethical principles do you think it followed? Did you have any concerns? Ethics isn't just about following rules. It's about fostering trust and ensuring that research benefits society without exploiting individuals. Take a moment to reflect on how these principles ensure responsible science. Now, while individual researchers uphold these principles, they don't work alone. Institutions play a critical role in enforcing ethical standards through something called an Institutional Review Board, or an IRB. IRBs are committees tasked with reviewing research proposals to ensure that they meet ethical standards. They serve as gatekeepers, protecting participants while ensuring that studies are conducted responsibly. IRBs oversee research in several different ways. First, they review proposals. Researchers submit detailed plans outlining their study purposes, their methods, and potential risks. Next, they assess risk and benefit. IRBs evaluate whether the potential benefits of a research study outweigh the risks to participants. Finally, they ensure compliance. IRBs confirm that studies follow ethical guidelines, such as obtaining informed consent and protecting confidentiality. Imagine a researcher proposing a study on stress involving a high-pressure task. An IRB might ask, are participants fully informed of the potential risks? Are there support systems like counseling in place if a participant becomes distressed? Is the study designed to minimize harm while achieving its goals? Here's what the IRB process typically looks like. A proposal is first submitted. Researchers provide a detailed plan, including recruitment methods, consent forms, and how data will be handled. Then there's a review process. The IRB evaluates the proposal, often involving multiple members with diverse experience. And finally, there's a feedback, revision, and approval process. The IRB might request revisions to address ethical concerns before granting approval. No research involving human participants can proceed without IRB approval. Why is this oversight so critical? Let's revisit the Tuskegee syphilis study for context. If an IRB had existed during that time, it's likely the study would have never been approved. The IRB would have flagged the lack of informed consent, the deliberate withholding of treatment, and the exploitation of vulnerable populations. IRBs are a safeguard against such ethical abuses, ensuring that participants' rights and dignity are protected. We've talked about how ethics safeguard participants and ensure fairness in research, but ethics alone don't guarantee that the results of a study are reliable. In recent years, psychology and other scientific fields have faced a significant challenge, what is known as the replication crisis. What does this mean? It means that many studies, when repeated, fail to produce the same results as the original. And in science, replication is crucial. It's how we confirm that findings are robust and not just flukes. There are several reasons why some studies don't replicate, ranging from pressures within academia to subtle errors in research design. Let's explore the most common culprits. The first is publication bias. Journals love positive results and studies that show significant effects. But this creates a problem. Studies that don't find an effect often go unpublished, even if they're just as valid. This is sometimes referred to as the file drawer problem. Many null findings are relegated to the back of a filing cabinet rather than being published in a journal. This leads to the published literature becoming skewed, giving the false impression that certain findings are more reliable than others are. Next up, we have p-hacking. Under pressure to publish, some researchers engage in something called p-hacking, which is tweaking their analyses to produce statistically significant results. The p in this case refers to the mathematical threshold that we use to evaluate whether research findings are significant or not. Ways that some people engage in p-hacking might include analyzing data in multiple ways and only reporting the ones that work, adding participants after a study is completed to push results over the significance threshold, doing multiple analyses of a data set without adjusting for multiple comparisons. These behaviors can lead to findings that seem statistically significant, but might not hold up under scrutiny. Next is small sample sizes. Small samples can produce unreliable results because they don't adequately represent an entire population. For example, a study with 20 participants might show a strong effect just by chance, but if you repeat it with 200 participants, that effect might disappear. Next is differences in methodology. Even small differences in how a study is conducted, like participant demographics or slight changes to instructions, can influence results. This makes it harder to replicate findings exactly in replication studies. Finally, there may be other contextual factors that play. Psychological phenomena don't exist in a vacuum. They're influenced by cultural, societal, and historical factors. A study conducted in one time or place might not generalize to others. To address these challenges, more researchers are embracing something called open science practices. This is a movement towards greater transparency and accountability in research. Key open science practices include pre-registration. Researchers will publicly outline their hypotheses and methods before collecting data, reducing the risk of p-hacking. Could include sharing data and materials, making raw data and study materials available for others to verify and replicate findings. It also includes publishing null results. Encouraging journals to publish studies that don't find significant effects can balance out the research landscape. By adopting these practices, we can help rebuild trust in research and strengthen the foundation of scientific knowledge itself. Let's reflect. Imagine that you're designing a study. How would you ensure that your findings are replicable and transparent? What open science practices might you adopt? This is a question that every researcher should ask themselves. Replication isn't just a scientific necessity, it's a commitment to integrity and truth. Today, we explored two fundamental challenges in psychology research: maintaining ethics and ensuring reliability. Let's take a moment to review what we've learned. We started out by reviewing the atrocities that occurred in the Tuskegee study. We took a look at ethical principles, examining the core principles of voluntary participation, informed consent, risk minimization, confidentiality, and anonymity. These principles protect participants and ensure that research respects human dignity. We discussed institutional review boards, or IRBs. IRBs play a critical role in overseeing research proposals, assessing risk, and ensuring ethical compliance. And finally, we talked about the replication crisis that's occurring in science right now. It encompasses the inability to replicate many studies, and it has highlighted issues like publication bias, p-hacking, and small sample sizes. Open science practices like pre-registration and data sharing offer a path forward for restoring trust in research. Let's finish up with a bit of review. Which of the following best describes the purpose of an institutional review board, or IRB? A, to publish significant research findings. B, to ensure that research follows ethical principles and minimizes risk to participants. C, to replicate studies and verify the results. Or D, to train researchers on statistical analysis techniques. The correct answer is B. IRBs ensure that studies are ethically sound and that participants are protected. What is one key practice of open science that addresses the replication crisis? A, using small sample sizes to reduce complexity. B, publishing only statistically significant findings, C, pre-registering hypotheses and methods before conducting the study, or D, avoiding replication studies to focus on novel research. The correct answer is C. Pre-registration increases transparency and reduces the likelihood of questionable research practices. As we wrap up, consider this. Maintaining high standards in ethics and making sure that our research is replicable, these aren't just challenges, they're opportunities. They remind us that science isn't perfect, but it's self-correcting. By prioritizing respect for participants and striving for transparency, we ensure that research meaningfully builds our knowledge base for the benefit of humanity. Trust isn't built overnight, and through careful, ethical, and reliable work, we can build a stronger foundation for the future of science. This concludes Module 2 on research methods. In our next module, we'll shift gears and take a look at cognitive models of psychology. But as you move forward, carry these lessons with you, because ethical and reliable research is the backbone of everything we do. As always, thank you for joining me on this journey into the science of the mind. Stay curious, stay resilient, and above all, live life in flux. Flux out. See you in the next lecture.